A+ലേക്കുള്ള വഴി ഇനി തനിയെ തുറക്കാം. Subscribe to the ENCLAPS channel. Ring the bell button and open success. It's that easy.
Hi. Lenses are transparent spherical surfaces which can either converge or diverge the light rays after refraction. Lenses can form images. As you have studied in the case of mirrors, if we place an object near the lens and vary its positions by changing the distance from the lens, you can observe that the images are formed at different points. When more than one ray of light converges or appear to converge at a particular point, an image is formed at that point. Using this concept, we can find out the position of the image and its characteristics when the object is placed at different position from the lens. We can make use of ray diagrams here, and this method is called the graphical method. There are some points you should take into consideration while drawing a ray diagram. Do you remember what a thin lens is? Yes, thin lens is a type of lens whose thickness is very small compared to the radius of curvature of the lens surfaces. When a ray of light passes through the optic center of a thin lens, either convex or concave, the ray does not undergo any deviation. It passes through the lens obliquely without getting deviated. A ray of light falling parallel to the principal axis of a convex lens will undergo a deviation and pass through the principal focus after refraction. A ray of light falling parallel to the principal axis of a concave lens will diverge away, and if we extend the ray in the opposite direction, it appears to diverge from the focus of the same side of the lens. A ray of light is passing through the principal focus of a convex lens passes parallel to the principal axis after refraction. So, using these rays, we can draw the ray diagram and find the image positions and their characteristics. There are 6 major object positions. They are at infinity, beyond 2f, at 2f, between f and 2f, at f, between f and the lens. Let's consider each of the situations in the case of a convex lens. In the first case, the object is said to be at infinity. This means that the object here is a distant object. The light rays are coming from a distant object and are considered as parallel rays. Therefore, the rays are parallel to the principal axis of the lens. We know that the rays coming parallel to the principal axis of a convex lens pass through the principal focus. Let's draw 2 parallel rays there, and after refraction, they converge on the principal focus of the other side. So, the image formed will be on the focus. What will be the nature of the image? The image formed will be a diminished one. Since the rays are really meeting at a point, the image is said to be a real image. You may recall from the previous experiment that an image formed by a distant object is an inverted image. We can summarize these details in a table. If the positions of an object is at infinity, the image will be formed at the focus, and the image formed will be a real, inverted and diminished one. In the next case, the object is placed beyond 2f. O is the position of the object and OB is the object height. We consider 2 rays here. The first ray is coming parallel to the principal axis. After refraction, it passes through the principal focus. The second ray is passing through the optic center or pole. It does not undergo any deviation and continues to travel in the same straight line. These 2 lines are meeting at a point M, which is in between f and 2f. Here, I is the image position and Im is the image height. From the ray diagram, it is clear that the image is formed between f and 2f. It is a real image and since it is formed below the principal axis, the image is an inverted one. OB is greater than IM, so the image formed here is diminished. If the object is placed beyond 2F, the image will be formed between F and 2F and the image will be a real, inverted and diminished one. In the next case, the object is placed at 2F. O is the position of the object and OB is the object height. We consider two rays here. The first ray is coming parallel to the principal axis. After refraction, it passes through the principal focus. The second ray is passing through the optic center or pole. It does not undergo deviation and continues to travel in the same straight line. These two lines are meeting at a point M, which is just below to 2F. So, the position of the image is at 2F. Here, I is the image position and IM is the image height. It is a real image and since it is formed below the principal axis, the image is an inverted one. Here, OB is equal to IM. So, both the image and the object have the same size. If the object is placed at 2F, the image will be formed at 2F itself but on the opposite side. Image will be real and inverted and have the same size as the object. In the next case, the object is placed between F and 2F. O is the position of the object and OB is the object height. We consider two rays here. The first ray is coming parallel to the principal axis. After refraction, it passes through the principal focus. The second ray is passing through the optic center or pole. It does not undergo deviation and continues to travel in the same straight line. These two lines are meeting at a point M, which is beyond 2F. So, the image will be formed beyond 2F. Here, I is the image position and IM is the image height. It is a real image and since it is formed below the principal axis, the image is an inverted one. Here, IM is greater than OB. So, the image formed here is a magnified image. If the object is placed between F and 2F, the image will be formed beyond 2F. Image will be real, inverted and magnified. In the next case, the object is placed at F. O is the position of the object and OB is the object height. We consider two rays here. The first ray is coming parallel to the principal axis. After refraction, it passes through the principal focus. The second ray is passing through the optic center or pole. It does not undergo any deviation and continues to travel in the same straight line. If you observe, you can see that these lines are parallel. Parallel lines will meet only at infinity. So, the position of the image will also be at infinity. The image will be a real one and since the rays are going below the principal axis, an inverted image may be formed. The image will be much larger than the object. If the object is placed at F, the image will be formed at infinity. Image will be real, inverted and magnified. In the last case, the object is placed between F and the lens. O is the position of the object and OB is the object height. We consider two rays here. The first ray is coming parallel to the principal axis. After refraction, it passes through the principal focus. Second ray is passing through the optic center or pole. It does not undergo any deviation and continues to travel in the same straight line. Here, the two rays are diverging apart, which means they never intersect. So, let's extend these rays in the opposite direction. By extending, they appear to meet at a point M, which is in between F and 2F. The image is said to be formed at I and the height of the image is IM. In this case, the rays are not really meeting at a particular point. Instead, they appear to meet at a point. So, the image formed here is not real. It is a virtual image. A virtual image cannot be obtained on a screen. The image is formed above the principal axis. So, the image is erect. IM is greater than OB and hence the object is magnified. If the object is placed between F and the lens, the image will be formed between F and 2F on the same side of the object. The image will be a virtual, erect and magnified one. From this table, you can easily understand that for a convex lens, how the position and nature of the image changes with respect to the positions of the object. Now, let's consider the image formation in a concave lens using ray diagrams. Concave lens is a diverging lens. So, the nature of the images will be much different from the convex lens. Here, we consider an object in front of the lens. The object is placed at O, which is beyond F, and OB is the height of the object. The first ray is coming parallel to the principal axis. Since it is a concave lens, the ray will diverge away after refraction. The second ray is passing through the optic center or pole. It does not undergo any deviation and continues to travel in the same straight line. These rays will never intersect. So, we are extending these rays backward and it appears to meet at the other ray at a point M, which is between F and the lens. The image is formed at I and the height of the image is IM. Since they do not intersect really, the image formed will be a virtual image. It is formed above the principal axis. So, it is an erect image. IM is much lesser than OB. Therefore, the image formed here will be a diminished image. The image formed by a concave lens will be virtual, erect and diminished. It will be formed near the lens. Now, do you understand how the letters appeared bigger while viewed through a drop of water? Here, the water droplet can act as a convex lens. Since the distance between the lens and the object, which are the letters, is small, the image will be magnified. Therefore, the letters appear bigger. In this session, we have learned the image formation in a convex and concave lenses and how the position and the nature of the image changes with the change in the position of the object.
3 ലക്ഷത്തിലേറെ വരുന്ന ചോദ്യോത്തരങ്ങൾ ഏറ്റവും കുറഞ്ഞ ചിലവിൽ സ്വന്തമാക്കുവാൻ ഉടൻ തന്നെ ഡൗൺലോഡ് ചെയ്യൂ എൻക്ലാപ്സ് ദ ലേണിംഗ് ആപ്പ്.